Good afternoon. Today is 14th August 2025, around 3 p.m. in the afternoon, and I am here in Gurgaon, Haryana. I just want to talk about the wind energy. Wind energy, it's a part of the renewable energy, and we create the power from the wind, and that wind is the source of our power, and and the wind is very useful for us. So many megawatts of energy is produced by our team, and we work towards building towards make our country more resilient, and it is very much required. So the today agenda is I just want to talk about the substations, which are one of the most important part of our projects. So substations are basically it's sort of a station for our electrical power which we generate. That means at the voltage at which we generate electricity, we have to step it up. We have to step up that voltage, and if when we step up that voltage, that stepped up voltage, the power, it goes to the power grid, to the CTU, which we call Central Transmission Utility. Well, we have to step up the voltage. There is a requirement of it. Why we have to step up the voltage? Well, the voltage is had to be step up because if the current value is very high, there would be very much losses in a transmission line. So, in order to fight those things, we step up our voltage, so the current value becomes less. The power is always constant, but when V goes upper on the upper side, current goes on the downward side, and P is equal to VI. It's a basic formula in the electrical industry. So that's why we use the substation to step up our voltage, and in order to minimize the losses. And one of the most important thing in the substation, in our all power evacuation system, we have to make our project financially viable. So to make our project financially viable, we have to make we have to calculate the losses, and the losses should not be on the higher side. They should be on the lower side. So we try to make our losses in the range of 5%. The losses should be in round about 5%. And firstly, in our power equation system, there is WTG, wind turbine generator. Then there is a small transformer associated with all the WTG in the unit substation. From our generator, 690 voltage of 690 voltage of electricity. 690 voltage is the input voltage is there, and the current value is around 2500 amperes. Roughly, all our WTG on which we are working is 2.7 megawatt, and the current can be calculated very easily. If 690 voltage is there, so around about 2700 ampere current is there, and that 2700 ampere current, if we want to transmit it to our own substation, our own pooling substation, uh, by uh, just transmitting that current, there would be many much losses. So in a unit substation, we use a transformer which steps up it to the 33 kV. 690 volt is stepped up to 33 kV. With respect to it, also our current value comes less. Around about it comes around 60 to 70 ampere, we can calculate it. It's very simple calculation. If we put in the value p is equal to 3 root 3 vi cos phi, if we take cos phi, but the power factor around 0.95, and voltage we take 33 kV, and power is 2.7 megawatt, then I can be calculated very easily by a simple divisible method, and it comes around 60 to 70 ampere, like that. So this current which is 60 to 70 ampere, it comes in a transmission line, the 33 kV line. It comes in our 33 kV line, and it goes to the substation. So in one of our substation, uh, we are evacuating power. We are evacuating the power of around of around 70 megawatt in one substation, and in other substation we are evacuating around 150 megawatt. So in our 150 megawatt project, we are taking the 220 kV power transformer. So what's the reason of taking the 220 kV power transformer? The reason of it is very fairly simple. We want to we want to make the project a financial success. To make the project a financial success, we have to step up the voltage and also reduce the losses. So in a substation, so coming back to our main topic, what is there in the substation? In substation, there are many equipments. Firstly, there are many equipments, and firstly and secondly, there is a protection system which we use. If in case of any fault, or that protection system would help us to fight those faults. And thirdly, there is a earthing system also, and fourthly, there is a communication system which communicates with the substation which is in the power grid. So this is the basic framework. So in a substation, there are two to three different types of bays. Firstly, there is an incomer bay in the 33 kV side, from which the power comes from the every WTG. There in the 33 kV side, there is an input of the base. Then there is a main control room also on the 33 kV side, which monitors the power, and which is also connected to the SCADA. In the main control room, there are panels, and in those panels there are relays also. Uh, uh, we also measure the power, and we also use the protection system. Then after that panel, uh, there is a cable which goes to the input of the 220 kV transformer. So the sorry, yeah, it is 220 kV transformer, but uh, it is it can be said as a 33 by 220 kV transformer which we use. The 33 kV by 220 kV transformer. Yeah. Sometimes there is also different voltage level. There is 33 by 132 kV. It all depends upon the schemes. It all depends upon the losses. But the basic framework right now in this time, 33 by 220 kV is very much feasible. It's a very much feasible voltage. So we use 33 by 220 kV system, and the power is input. The power from the primary side is input to the transformer uh, from the 33 kV side, and then it is stepped up to 220 kV side, to 220 kV level. The voltage is stepped up to 220 kV level. Uh, we also calculate the cables, the number of runs of cable which we calculate in our calculations. It is very much important how much run cable per phase is required, how much earthing is required. So the cable are selected. The cables are selected uh, by seeing the current level. It all depends upon how much current is you are providing to the input of the transformer. So by seeing all this, and we refer to the cable catalog, we refer to the cable catalog, how much square cable is required. So sometimes 630 square cable is also okay. So sometimes 600 square It all depends upon the manufacturer, and costing is there in that. Okay, how much cable is required, how much everything is required, and then from that cable goes